All right, hi there. So in this video, we're going to look at how to do some calculations with a normal distribution using StatCrunch. So I've pulled this problem here out of a textbook like yours, and it's about commute time to work. So let's just read through that quickly. The average commute time to work is 25 minutes according to the 2005 American Community Survey. If we assume that commuting times are normally distributed and the standard deviation is 6.1 minutes, what is the probability that a randomly selected commuter spends more than 30 minutes commuting one way or less than 18 minutes commuting one way? So just to recap, we have average commute time to work. So that's our variable. And the mean, or commute time to work is our variable. The mean is 25 minutes, and the standard deviation is 6.1 minutes. And happily, they told us that it follows a normal distribution. If we select if we randomly select a commuter, we've got these two probability questions that were in the actual problem itself, and then I added a third one, and then I added another question about commute time. So we're going to take those one at a time and find the answers using StatCrunch. So let's just quickly jot down what we know. Our variable x is commute time, and so then we know that the mean of that is 25 minutes, and the standard deviation is 6.1. You have to be familiar with those symbols, of course. And then we know we have a normal distribution, which is really, really important. And so we have that information, so we can use the StatCrunch normal calculator. So I'm just going to go to StatCrunch. If you're not already in StatCrunch or you're not opening it from an exercise, then just go to statcrunch.com, use your MyStatLab credentials to get in, and then open StatCrunch. Hopefully you've done this before. And we're going to go to Stat Calculators Normal. Stat Calculators Normal. We've got two options, standard or between. The default here is standard. Our mean is 25. The standard deviation is 6.1, so I'm going to go ahead and put those in. And now let's go back to the probability question for a minute here. The first probability question, part A, probability that the commute is more than 30 minutes. More than is greater than, so if we were to translate that, that would be the probability that x is greater than 30. And so here we're going to go back to StatCrunch. We're going to put in, switch the inequality to greater than. Greater than versus greater than or equal to makes no difference with a normal distribution because it's continuous. And then just click compute, and notice that right here we get 0.2062. So if we round to, let's say, 3 decimal places, we get 0.206. So I'm going to go back, and I'm just going to mark that down as the answer here, equals 0.206. Okay. So the next question is the probability the commute time is less than 18. Well, this is really no different except for it's a less than. And so this is really the probability that our variable, in this case x, is less than 18. And so we're going to go back to StatCrunch. And we still have the same mean and standard deviation. We're now going to switch the inequality to less than and put in 18. Notice the curve goes away. Don't let that make you nervous. It's computing something, and so it doesn't want to show you the old picture. So it takes away the picture. Once you have 4 of these fields filled in, well, you always have to have the inequality field filled in. But once you have the mean, standard deviation, and then either the number inside probability or the number outside probability filled in, you can click compute. It'll have enough information. Notice the curve here is showing this highlighted area to the left because less than is left. And so this red area here is represented by the answer to the probability. So that 0.126, let's say if we go to 3 decimal places. So that's 0.126. Let's go ahead and put that answer back in there. And so now for the next one, commute time between 15 and 20 minutes. So in inequality notation, that's going to look like probability 15 is less than our variable x is less than 20. So notice that the x, the variable value, is stuck between the 15 and the 20. And so this is a between question. And that in StatCrunch, you're just going to click on between. So the less than and the greater than are standard. Between, you have to switch over. Our mean and standard deviation are still the same. We want between 15 and 20. Notice again the picture went away. We put in the endpoints that we want the probability for. We click compute. Shows the area between those two values. Notice it gives you a number line on there. And so we have 0.156 approximately to 3 decimal places. And so that one's 0.156. Okay. And finally, this last one here is a very different question. It's not a probability question. It's not asking us what percentage. It's asking us really about the commute time itself. The 10% of Americans that have the longest commute time spend how much time on their commute. So this is asking us, remember that X is commute time, and they're asking us for the value of that, and they're relating it to the top 10% or the 10% of Americans with the longest commute. So if we were to think about what that means, we're really looking for here the probability that the variable is bigger than something, right? So think about the curve. This is where I find that the curve really helps me. If I'm going for a normal curve here, let's just see if we can't draw a normal curve. No? Okay, pretend we're doing it from here. So if we're looking at a normal curve here, right, underneath it is the number line for commute time. It's centered at 25 minutes. It's a little messy. The 10% with the longest commute time. So the longest commute times are up here, right? There'd be a cutoff somewhere up here. We're looking at all these people that are up here on the number line, right? So what is this value right here? Because anyone that has a longer commute time is going to be on this end of the scale. So we know that this has got to be the top 10%. So this is what I call a reverse normal question. So sloppy, sorry. So we're looking for this top 10%. So what is that value of X, right? So if we knew that value, then the probability X is bigger than that would be 10%. So I'm going to go back to StatCrunch here. It's a greater than, right? So we don't have a area or a percentage between. We know that 10% are bigger than the number we're looking for. So it's a standard problem because it's a greater than. And so we still have the same mean and standard deviation. We know we're looking at a greater than, and this 18, clearly that's 87%, right? And we're looking for 10%. So I'm going to take that out. And I don't know that value of X, but what I do know is that the probability that a value or commute is longer than that is 0.1 because I'm looking for that top 10%. So I put that 10% in there as the value of the probability that X is greater than some number. So notice I left a blank inside the value of X. So the probability that X is greater than some commute time is 10%. So take a look, see how that picture matches what we're talking about. And then this box got filled in 32.8. So this right here is about 32.8 minutes, right? Here's that average of 25. And so the 32.8, this red area is that 0.1. So about 32.8 minutes. So 10% of Americans spend more than 32.8 minutes commute time. 32.8 minutes or more. Right? So there's really, there's 4 different types of questions you're going to work with the normal distribution. It's either going to deal with something less than, and you're looking for the percentage of the probability, or more than, or between. Sometimes you might be looking for outside the middle, and so you got to be a little bit more creative there, but I think you can handle that. And then you'll be given a percentage or a probability and asked to find the value of the variable that goes with that. So there's an example of those 4 most common questions about normal calculations and how to do it in StatCrunch.